Okay, so recording has been started. Now, today our topic of discussion is, the convolution, and it is the most important topic of the signal system. And okay, the screen is not coming right now. I'm waiting for the screen. Okay, please mute your mic.
ఫోన్ కానీ అక్కడ చెప్పినా పోయేదిరా నేను ఇంకా విడిగా
Mahesh Babu.
ఉంటాయిలే.
Mahesh Babu. Okay, so see, I have started today the convolution. Okay, so today date is 19. So what is the convolution? You have to understand it. What is the convolution? So convolution, before going to the details of the convolution, just we start with the basically it is a mathematical, it is a mathematical operator, and it is used for calculation of response. Always remember response of LTI system. LTI system, right? We have already seen what is the LTI system, linear time invariant system. So YT is represented by the convolution of, let's say, x1t convolution. This is the convolution sign, okay, with x2t, or it is nothing but the integral. It is nothing but the integral minus infinity to infinity x1 tau dot x2 t minus tau d tau. So always remember x1t convolution with the x2t is nothing but the minus infinity to infinity x1 tau into x2 tau t minus tau d tau. Okay, so this one is the definition. This is the formula for the convolution, right? So before going to the details of this mathematical term, this mathematical term, we will start with some previous point. Whereas what is the significance of convolution, if you want to know. So let's say this is the LTI system. And you want to apply some of the input xt, and there is, let's say, yt is the output. So yt, the response of this LTI system, may be calculated, may be computed with the help of yt convolution technique, that is the xt into st. Or what is this? This is nothing but the impulse response of the system. So basically, why the convolution is used? Convolution is a linear time invariant operators. As I have all told you, the convolution is only applicable for the LTI system, and it is used only for LTI system. Only for the LTI system, nothing else, right? So how it is used? So again, I have told you yt is equals to nothing but the minus infinity to infinity, or you can say t h of tau x t minus tau, or you can write x tau ht minus tau. Both are the same thing. You can also write as x tau h of t minus tau d tau. Both are the same. The equation number 1 and equation number 2 both are the same. Right. Now the question is what the condition of LTI system to be static? So see, condition for LTI system to be a static, right? So Mahesh Babu, please you tell me what is the criteria for the static? Mahesh, I will mark you absent otherwise. Static. What do you mean static? No idea. Mahesh Babu, absent. Okay. Chandan Kumar,
Yes, sir.
what do you mean by static?
It's a static function.
Yes.
सर ध्यान नहीं आ रहा मेरे को.
बस तो फिर absent ही हो, कोई बात नहीं. Heidi Brand,
Yes, sir.
what do you mean by a static system?
Static system, sir.
कोई बात नहीं, इतना टाइम नहीं. कुशाल अग्रवाल,
Yes, sir.
what do you mean by static system?
सर वो सिस्टम जिसका आउटपुट सिर्फ प्रेजेंट इनपुट पे डिपेंड करता है.
Okay, very good. Okay, good, very nice, very nice. So the condition for the LTI system to be static, the LTI system को static होने के लिए what is the condition, what is the criteria? Just to see, let's say we have a output yt relation with the input like kxt. Yt is equals to kxt, right? Now you want to put the xt value, input value, as a impulse input. Okay, you have put the value, input value, as a impulse value. So the yt is known as nothing but the ht. Okay, it means the relationship between the output and input, that is the yt upon, when you put xt equals to delta t, it becomes k into delta t, right? K into delta t. It is k into delta t, and it's nothing but the output st. It is known as the output st. So how it is represented? It is represented like this. This is, sir, this is the k. Your ht is there. This is the time. Okay. Now, when you are talking about the transfer function or the frequency domain, so you can represent y omega. Okay, what is y omega? Y omega is nothing but the y omega upon x omega, or x omega is this is the transfer. What is the Laplace transform of delta t? Yes. Anyone? What is the Laplace transform of xt delta t? Ashutosh Dureja. Ashutosh Dureja.
Yes, sir.
What is the value of x delta t? What is the Laplace transform of delta t?
सर याद नहीं आ रहा.
याद नहीं आ रहा? बिल्कुल बेवकूफ हो गया. What is the Laplace transform of delta t? इसको याद क्या करना है? But why you are going to remember this one?
Sorry, sir.
It is not a matter of sorry, It is a very easiest thing. If you don't know about the Laplace transform delta t, how can you solve this, any problem with the signal system? In the last exam, you are going to just copy. So the Laplace transform of this, as 1. So just you put it y omega. So it becomes k. Okay. And it means when you plot it, this is x omega. X omega is nothing but the, x omega is nothing but the 1. So it becomes h omega. H omega is this k. And when you plot this one with respect to the omega, this one is, this k is like represented like this. This is the h omega. So what it means, when you are the continuous signal in the time domain is now the continuous, this discrete time signal, the discrete time signal in the time domain becomes a continuous signal in the frequency domain, and vice versa. So you can say that impulse delta t is the function whose all value, whole x form is 1, nothing else, right? So, and for a static LTI system, impulse response should be impulse at origin. Yes or no? In the time domain. In the time domain, you can see that for the LTI system, impulse response should be impulse at origin. However, in the case of frequency domain, you can say that the transfer function should be independent of frequency. So this question may be asked in your exam. So you can say from some example. Let's say I'm giving one example. What example? And comment on their static and dynamic of the LTI system. Right? Check static and dynamic of the LTI system. So let's say I'm giving Dureja. Tell me the answer. Is it a static or dynamic? Is this a static or dynamic?
Yes, 1 minute, sir.
Huh?
1 minute, sir.
No minute is required for giving the answer. Not a single minute is required. Yes, Karanjit. Okay. Manas. No problem.
Yes, sir. Static.
Yeah. Static. Why it is static?
So because it is depending on only the current value.
Okay. So it is only, this is the impulse response is only at the origin. Okay. However, in this case, let's say this is the 2. So you can directly say that impulse is not at the origin. Impulse is not at the origin. And therefore it is a dynamic. Right. Okay. Now third example is the ST is equals to, let's say, UT. The output, this response, the response is UT. So you can say that is the dynamic. However, if it is the ST is equals to, you can say this, like the response is like this one. What is your comment? It is the static or dynamic? Static or dynamic? Yes, students.
Static, sir.
Why it is, who says the static? Rishabh.
Yes, sir.
Why it is static?
So its function, I think it's e to 1 upon e to the power t.
Yes.
E to the power minus e to the power minus t. Oh, okay.
Huh? So
So now it will. So sorry, sir. It's dynamic now. Dynamic.
so it's
I
a dynamic because it depends on the past value.
past value. Yes, sir. I thought this function
Okay,
is
no
e to the
problem.
power t.
HSH equals to 2. What is the comment? It is a static or dynamic? HSH equals to 2. It's a static or dynamic? Yes, Dureja.
Sta- Static,
Dureja.
sir.
Dureja.
Yes, sir.
Yes, what is the answer?
स्टैटिक बोल दिया उसने
हाँ क्यों उसने स्टैटिक बोले स्टैटिक है
सर वो
Why is it
इनपुट
static?
8 दो सर जो जिसके इनपुट एक मिनट जिसके आउटपुट वैल्यू इनपुट में डिपेंड करे
आउटपुट और इनपुट डिपेंड करे कुछ ही बोल रहा है पढ़ लो नहीं तो फेल हो जाओगे मैं लिख के दे रहा हूँ
यस सर
So let's say HSH equals to S plus 1 upon S plus 1. Yes. Aditya, what is your comment? Static or dynamic? आदित्य
सर
कुमार
ये डायनेमिक लग रहा है सर
क्यों
डायनेमिक सर
क्यों
क्योंकि सर ये फ्रीक्वेंसी पे डिपेंड कर रहा है ना एक तरह से
फ्रीक्वेंसी पे भी डिपेंड कर रहा है यस और अगर तुम इसका उल्टा जाओ तो इफ इट इज द इंपल्स रिस्पांस सो इट इज द इंपल्स रिस्पांस इट इज माइनस टी नथिंग एल्स यस और नो सो आप दोनों तरीके से देख सकते हैं इट इज डिपेंड्स ऑन द फ्रीक्वेंसी एंड दिस इज
Yes, sir.
ऑल्सो डायनामिक यस दिस इज द डायनामिक सिस्टम वेरी गुड सो नाउ
सर फ्रीक्वेंसी से कैसे पता किया?
सॉरी
सर फ्रीक्वेंसी से कैसे पता किया
ये
कि
मैंने
ये
आपको एक कंक्लूजन बताया अभी अभी जस्ट ये आपको मैंने ड्रॉ किया इसलिए For the static LTI system, impulse response would be impulse at origin. Transfer functions would be independent of frequency. ये दोनों पॉइंट जो है ये मैंने बताया आपको ठीक है ओके नाउ मूव टू द नेक्स्ट पार्ट I'm not in the details of the stability okay okay so So now come to the convolution part. So convolution, before going to the details of the mathematical operation of the convolution, just to write down some of the points regarding the convolution. So convolution is, it is a mathematical operator, mathematical operation applied to two functions. Right, two function that is your x1 and x2 whatever of the and the function should be from the nature of the function should be same independent variables right so what is the result when you applied some mathematical operator to the two function that is x1t let's say x2t so what is the result so it results into a third function. It is a third function. You got a third function of the same independent variable as used in applied function. Right? So this third function, जो third आपको मिला, whatever you got, third function, this third function is called the convolution of two function. Right? Convolution of the two function. Right? Okay. So always remember, convolution integral is also referred as superposition integral. Can anybody guess? I have given the answer of this question. Can anybody guess why it is called a superposition integral? Why it is called a superposition integral?
सुपरइम्पोजिशन से थर्ड फंक्शन बनेगा.
Sorry शुक्ला जी.
फर्स्ट और सेकंड फंक्शन जो हमारा इंडिपेंडेंट वेरिएबल्स का होगा उसके सुपरपोजिशन से थर्ड फंक्शन बनेगा.
Yes, it is one of the correct answer. Other answer is it is only used convolution. I have given the answer. It is only used. It is only used to compute the response of a continuous time LTI system, linear time invariant system होना जरूरी है, with impulse response HT, right? For any arbitrary input xt, right? So how it is defined? It is defined mathematically as yt is equals to nothing but the x of tau h of t minus tau d tau, right? So it is nothing but the x of t convolution with h of t, right? X of t convolution with the h of t. This is a mathematical equation, mathematical definition, right? And if we are going to the detail, so if it is impulse response, so it is nothing but the delta t minus tau d tau, right? So now come to the mathematical system, mathematical equation, how it is calculated. So when you're talking about x1t dot x2t, when you're talking about the convolution of yt as x1t convolution with the x2t, okay, and it is defined minus infinite to infinite x1 tau multiplied with the x2 t minus tau d tau. So we have seen x1t convolution with the x2t is nothing but the minus infinite to infinite x1 tau into x of x2t minus tau d tau. So how it is calculated? So if you have two function, and you want to calculate the convolution, it is very, very important. If you don't know about the convolution and how it is calculating, how the convolution of the two function is going to be computed, so even you can't understand the Fourier transform and Fourier series. Fourier transform, okay, not the Fourier series, but you can't understand very comfortably. We will not be comfortable in the Fourier transform. So my suggestion is just to remember this one, and it is very important for any of the techniques are used in anywhere. Okay, so convolution is used everywhere. When you handle with some of images or data, or all these things, all these stuffs, right? So what you have to do, first of all, x1t, what is the step? I am writing the step how to calculate. So you can see that first of all x1t is replaced by x1 tau, t is replaced by the tau, okay, t is replaced by the tau, and x2t again it is replaced by tau, x2 tau, and then x2 tau is replaced by reversing x2 minus tau. You can see here, first of all I have replaced by x2t by tau, then I have I have applied the reversal rule or the folding rule, and then this x2 minus tau is shifted, x2 to tau minus shifted by, you know, minus of, you can see here, tau minus t. So it becomes same, yes or no? It is shifted and then reversal, so it becomes same. And now you are going to multiply this signal x1 tau with this signal. So just to have taken the multiplication and then integrate, you can found like this. So first of all, you got the x1 tau by doing this operation. You have done x2 t minus tau with the help of folding and shifting operation, and then multiplied, and then you have taken the integral, right? So what are the different steps involved in this convolution? So first one is your folding, that is a reversal. Second one is a shifting. Third one is the multiplication, and fourth one is your integration. So these four techniques, these four steps are involved in order to calculate the convolution, right? So I am taking one. You can ask any query if you have in mind, because it is very important. I will ask the problem. It's okay? Yes or no? Is it okay? Tell me.
Yes, sir. Yes, sir.
Okay. Okay. So let's say I'm taking the first example, and very famous example, the very common example. Yt is equals to, you have to, if you want to calculate the convolution of ut. Convolution of ut. Okay. So first I am going to solve this question. Okay. And after this, we will solve and tell me the answer. Okay. So what you have to do, this is the x1t, this is the x2t, right? So x tau minus ht minus tau, okay? Where xt, if you have taken xt is equals to ut, and ht is again your ut, okay? So when you calculate minus infinite to infinite x tau, h of t minus tau d tau, you have to do like this, right? So first of all, what is the u tau? Okay, what is the u tau? So u tau, when you replace the ut, so your ut, like ut becomes like this one, right? So this is your u tau, this is your u tau with the t, right? Now come to the ut minus tau. You need u t minus tau, or you can say like this, u of minus tau minus t. Both are the same thing. Yes or no? Both are the same thing. You need this one. You need this one. So first u tau, if you got u tau, okay. Then how it will be got you? How you got u minus tau? So just you have to do, apply the reversal rule, and you got the u got the u of minus tau. So this is your u of minus tau. Nothing else, right? What is the u minus tau plus t? What is the u minus tau? Sorry. U of minus tau minus t. Okay. Or you can say simply ut minus tau, nothing else. How it can be represented? So first of all, u minus tau, क्या करना पड़ेगा? कोई बताएगा हमको? How it can be
शिफ्ट हो जाएगा t unit से, u
so
of minus tau वाला कर.
very good. So this one, this tau is, shifted like this one. If your t is less than 0 and it is shifted like this, if it is shifted like this, if t is greater than 0, yes or no? It is your ut minus tau, ut minus tau, u of t minus tau. You can see, okay? Or you can write like u of minus tau plus t, or you can write u of minus tau plus t. If your t is greater than 0, then it is shifted like this. If it is less than 0, it's shifted like this. You agree or not? Everyone is agree or not? Now tell me.
Yes, sir.
Okay. Okay. Good. So now tell me, when you multiply this signal, what you have to do last? You got ut minus tau. You got ut minus tau. Okay. You got it. St minus tau you got, x tau you got. What you have to do after the next step? Just to multiply. Okay. So multiply this two signal. So when you multiply the u tau, what will you got? When you multiply this signal with this signal, what you will got?
0.
0. Very good. And when you multiply, yes. So when you multiply this signal with this signal, you got 0, right? When you multiply this signal with this signal, then what you will got? Then what you will got?
सर 0 to
सर
t
0
1
से
होगा.
1 होगा, बाकी सब 0.
Very good. 0 to t, you will got like a pulse signal. Yes or no? Yes or no? 0 to t. Otherwise it is a 0 either and either 0. So when you multiply it with the signals, it is only like this. Now what you have to do? What you have to do? You have to nothing do, but you have to just take the integral from 0 to t of what? 1. 0 of t of 1. यही तो है आपका. यही तो आपका आने वाला है. Yes or no? So just to multiply, what you will got? You will got t. You will got t. Nothing but the t means ramp function. T means ramp function. Like this. Like this. You will got the output this. Yes or no? Yes or no?
Yes, sir.
So what is the conclusion? The conclusion is very important. The convolution. You have to remember this one. This question has been asked many times in the gate and the ES examination. UT, the convolution of UT is always remember RT. The convolution of UT in a step function is the RT. Another technique to calculate the this signal convolution. Always remember, convolution in time domain is a multiplication in frequency domain. Convolution in time domain equal to multiplication in frequency domain, right? And therefore we are using the Laplace and whatever the techniques. Why? Because Laplace is in the multiplication frequency domain, and you want to calculate the convolution, so you have to apply this steps in order to find the convolution. But the frequency domain is very easy to calculate. How? You know the frequency domain. You know the frequency domain of UT. UT is represented by 1 upon S. Yes or no? In the frequency domain. Yes or no?
Yes, sir.
UT is again represented by 1 upon S. This is a Laplace transform UT, Laplace transform UT. And when you multiply 1 by S into 1 by S, answer is 1 by S square. And when you return back, when you taking again the inverse response of this frequency domain, we are again converting this signal into the time domain. 1 upon S square means RT. Yes or no? TUT. Or you can say RT. Is it same? Yes or no? Tell me. अरे समझ में आ रहा है कि नहीं आ रहा है?
Yes, sir. आ रहा है.
TUT और RT is both are the same thing. 1 upon S square. परवीन अग्रवाल, CR is not here. Parveen, Anurag Soni is not here. Okay. Okay. So Pramod, now please conclude. What to understand now?
सर यही कि अगर हम कन्वोल्यूशन को अगर फ्रीक्वेंसी डोमेन में ले आते हैं तो इजीली कैलकुलेट कर सकते हैं बाय मल्टीप्लाइंग एंड देन टेकिंग लाप्लास इनवर्स.
Yes. So you can conclude it like this. If you want to calculate the convolution, or convolution is nothing but the multiplication frequency domain. So you can also compute when your function is not easy to calculate, then you can go like this also, right? But some of the function you have to remember. Some of the convolution you have to remember, like UT convolution kya hoga, like this, right? So now I'm coming to the next part, that is the properties of the convolution. Then I will proceed further. We have take the more example. So properties of convolution. First is the commutative. Let's say x1t convolute with the x2t. So it can be written as a x2t convolution with the x1t. There's no problem. Okay. Like this one, minus infinite to infinite, x1 tau into x2t minus tau d tau. I already told this property earlier. You can also write this as a x2 tau, okay, x1 t minus tau d tau. Both are the same. The result will be the same. There is no change in the result, right? Second one is the associative. It follows the associative. So what it means? x1t convolute with the x2t convolute with the x3t. Okay, there is no matter whatever you calculated. Let's say first you calculate x1t with the x2t convolution, and then you calculated the convolution with the x3t. You will got the same result. The result will not change. Okay. Third is the distributive. So x1t convolute with the, let's say, x2t plus x3t, right? x3t. So the result is nothing but the x1t convolution with the x2t plus x1t convolution with the x3t. Okay. The fourth example, is the impulse response. So always remember, it is very important. It's the most important example property. Let's say you are going to convolute xt with delta t minus t1. Remember, सभी लोग ध्यान सुने जो गेट के एक्सपेरिमेंट से बहुत इंपॉर्टेंट है बात. xt का हम कन्वर्सन करने जा रहे हैं डेल्टा t माइनस t1 के साथ. Result will be the same, xt minus t1, nothing else. Okay, because xt, based on this property, always remember xt convolution with the del t, you will got xt only. We have already seen in the integral, in the time of the integral. Just to apply, Just to apply the formulation what we have said earlier, xt, convert xt to the tau, okay, convert delta t minus tau, multiply and take the integral, you will got the same xt. We already have seen. Based on this property, based on these two properties, let's say I am giving the example. So in your problem, in your examination, just problem is given. Just problem will be given, and the problem, the question setter will ask what is, what is the convolution of this problem. Okay. So based on this ut minus 1 convolution the delta t plus 2, tell me what is the answer. Yes, Pratiksha. Now tell me what is the answer. Pratiksha is here. Pratiksha is absent. Okay. Gupta, Pransul.
Sir, ut plus 1.
ut plus 1. Very good.
एक बार sir. Yes, sir.
ut
Hello,
plus
sir.
1. Very good.
Yes,
Yes.
sir.
सर एक्चुअली सर माइक ऑन होने की जगह सर कैंसिल हो गया था मीट.
कोई बात नहीं, कोई बात नहीं. So what is the answer?
सर ut minus 3.
ut minus 3.
सर ut minus 1 इन सर प्लस 1 होगा सर ut plus 1.
ut minus 1 plus 2. Nothing but the ut
Yes.
plus 1 answer. Okay. So it is very important. Always remember. Always remember. ठीक है. Next example. Next property is the derivative. Derivative property. So you know yt is equals to x1t convolution with the x2t, as we know. So when you take the differentiation of d by dt of yt, so it will gives either the d by dt of x1t convolution with the x2t, or either x1t convolution with the d by dt of x2t. Always remember, d by dt of, you can utilize this property, differentiation of output, if you take the differentiation of output. So one of the input has been, you can take the derivative of the input, and then you can take the convolution with the other input, right? So let's say I'm giving one example based on this. Find yt. Find yt if yt is equals to d by dt of rt convolution with the ut. rt convolution with the ut. Okay. So can I tell you what is the answer? What is the d by dt of rt?
0 होना चाहिए.
0 होना चाहिए. क्या बात कर रहे हो?
सर आपने तो बोला
RT होगा.
RT will the answer. RT will the answer. Why RT will the answer? Why RT will the answer?
Sir,
You know, yes. So it will either represent d by dt of RT convolution with the ut, or either represent RT convolution with the d by dt of ut. Yes or no? The output will represent like this, either this one or this one. If you are taking this one, d by dt of RT, so it is nothing ut. d by dt of RT is ut. Again it will provide RT and RT, and when you take the derivative of ut, it is nothing but the delta t, and when you take the convolution of this one, again you will got RT, because when you follow the above property, xt into delta t, always the xt. Is it okay? Yes or no? Is it okay? दुरेजा,
Yes, sir.
समझ में आ रहा है?
Yes. हाँ जी सर.
थोड़ा थोड़ा.
नहीं आ थोड़ा आ रहा है. हाँ जी सर.
हाँ?
हाँ जी हम अभी जो कराया वो तो आ गया.
Okay. Next property is the step response. Next property is the step response. So yt is equals to xt convolution with the ut. Let's say you want to find out this one. So you can say yt is nothing but the minus infinite to infinite d by dt of yt dt. Leave that. Leave this one. Leave this one. I will discuss after some time. Okay. Okay, now tell me. I have taken some example. Let's say ut and convolution with the ut. Yes, Dureja. What is the answer?
RAM function.
Huh?
RAM function.
RAM function.
RT.
Now tell me RT convolution with the ut. Now what is the answer?
सर वो जो बनाया था आपने वो कैसे?
What is the answer? Yes, any other? Muhammad Salim.
Parabolic.
Parabolic. Good. Parabolic. Now I'm coming to the next time scaling. Next property, that is the time scaling. Time scaling property. So if x1t convolution with the x2t, let's say it is a yt, then the convolution of x of at, convolution of, sorry, x1 at convolution with the x2 at, what is the answer? The answer will be the 1 by mod a y of at. Y of at where a is not equal to 0. Where a is not equal to 0. This is very important again. We will use it, this property further. Next property is the area. If x1t convolution with the x2t, if it is output the yt, the response is yt, then area under yt is nothing but the whatever the area under x1t into area. You can calculate like also this. This is again, it is not very important, but sometimes it may be asked. Okay, so time delay. Next property, the time delay. And let's say the convolution of x1t with x2t is defined as a yt, and you want to calculate x1t minus t1 with x2t minus t2. So what is yt? Yt is nothing but it is the overall shifted with t1 and t2. Your response will shift like this. Now based on this, tell me the answer of the problem. ut minus 1 convolute with the ut minus 2. What is the answer? Dureja, what is the answer?
Yes, sir. So minus YT minus 3.
Why? Yt? Really?
तो Y नहीं
बोले सरकार,
सर XT minus 3.
x कहां से आ गया जब u है तो? कुछ भी बोले यार.
आपने ऊपर x का Y नहीं है ऊपर आपने.
अच्छा, x का y हो गया, इसलिए u का x हो गया, है ना? बताओगे या दूसरे प्लेनेट पे जाने की तैयारी कर रहे हो?
सर UT -3
First of all, just your on your camera. I want to see your
कैमरा नहीं ऑन अभी।
हाँ?
वहाँ जगह पे नहीं कैमरा ऑन करने वाले।
क्या? सॉरी,
जगह पे नहीं कैमरा ऑन करने वाले अभी।
अच्छा आप जगह पे नहीं है, क्यों नहीं जगह पर है?
सॉरी सर।
हाँ? You don't know at the 9:30 the class will be happen. And before
Yes, sir,
every
thank
class
you,
I have given the link before 10 minutes or 15 minutes.
Yes,
So
sir.
in that 15 minutes, why you are not getting ready?
Sorry, sir.
Irresponsible guy. Yes, Pransul, what is the answer?
सर R of t minus 3.
उसको बताओ R कहाँ से आया?
सर रैम फंक्शन UT का जो भी आपने
अच्छा
बताया।
पता चल गया रैम फंक्शन है, ठीक है।
It may be written like also this in the term of UT.